welcome to the final video of this section. In this video, we'll be modeling real-life scenarios with sequence and series and see applications of sequence and series to real-life examples. Alright, so in this first question, we've been told that Bruce starts a new company. He estimates that the year one profit will be £20,000, and he predicts that every year after the profit will increase by £5,000 a year, up to a point. So he then models that once his annual profit reaches £100,000, they will then remain constant. Alright. So the question is asking us to calculate the profit of Bruce's business in the first 20 years. Okay, so it might be tempting for you to think this is a straightforward arithmetic series, but let's see what the question is saying. Yes, it is an arithmetic series up to a point. So from year 1, 2, 3, and so on, his profit will be rising at a constant rate. Okay, it will be rising in a stepwise fashion. Okay, so it will be rising and rising every year. But once his profits hits £100,000, it will plateau and stay flat at £100,000. So first step we need to calculate is that what year is it that it will plateau out or it will flatten out. Alright, so that's the important part in this question here. Right, so we're looking for the nth value that will tell us the profit will equal to or will be greater than £100,000. We know, you see, £100,000 is actually a multiple of £5,000 and £20,000 added to it. So actually, it will start here at £20,000. So maybe I should have put my numbers down here because this is the flat curve. This is the values for n. All right. 1, 2, 3, and so on. Okay, so what we're going to do is use the u or the nth term formula for that's the arithmetic, that's for geometry sequence. The un for arithmetic sequence is simply a plus n minus 1d. So we know what value of a is. A is £20,000, and d changes the is an is a common difference, which is £5,000. So we are going to substitute these values into this equation, and we're going to replace un because we know that 100,000 will be the u the that year's profit. Okay, so let's see what's happening. We're going to substitute these into this formula and solve for n. Once we've solved for n, we'll see that n is actually 17. Alright, so after the 17th year, his profit will be flat. We are going to find out what's the earning, what's the sum of the earnings during the first 17 years. Now, the sum of the earnings during the first 17 years is given to us with sum of arithmetic sequence. Sum of arithmetic sequence is given to us with this formula that I'm circling on top of the page. So we're going to use n to be 17, and for the last 3 years we're simply going to add 100,000 for last 3 years. So 100 times £100,000 times 3 will be £300,000. That would be the last step of our calculations that we've just already looked at. So that's because year 18, 19, and 20 will be at the stage where the profits have flattened out. All right. So let's use the formula on top of the page and figure out the arithmetic sum. We're going to substitute 20,000 for A. D will be 5,000 £5,000 and so on. Alright, so we ended up with actually £1,020,000 for the first 17 years. Then we are now going to add £300,000 for the last 3 years, and this will be the total profit. That's cumulative profit over 20 years. Okay, so let's look at the next part of the question. We've already answered part A. Part B is asking us to state the reason why this model might not be suitable. Well, profits go up and down. They don't remain at a constant rate each and every year, right? So it's highly unlikely that Bruce's profit will increase by exactly the same amount every year. Alright, so let's look at the next part of the problem. Okay, in the next part of the problem, the question is saying Bruce's financial advisor says that it is more likely that his profit will increase by 5% per year. Using this model instead, calculate the total profit that Bruce will make during the first 20 years. So we are discarding what's going on up here. We are discarding the arithmetic sequence, and we are saying that the profit will increase by 5%. Now thinking back about your knowledge about percentage increase, that means percentage multiplier will be 1.05. Okay, so we're going to use a common ratio of 1.05. Now this is no longer an arithmetic sequence, but a geometric sequence. Alright, so we're going to take 20,000 to be the first year's profit, and then actually we're going to find out the profits for the end of the year. So this part of the model is the difference that you need to understand carefully. You start with a value at the beginning of the year, and you count your profit at the end of the year. So by the end of first year, we would have already multiplied by the common ratio once. So if you think about it, what happens at the end of the second year is we would have multiplied twice by it. At the end of the third year, we would have used the multiplier 3 times, and so on. So the nth term formula changes slightly. So previously we would have used this formula to calculate the nth term year, but now we are actually, because we are looking at the profit at the end of the year, we are going to use this formula instead. Notice the difference is n and n minus 1. We are actually going to use this. Alright, so we have A to be 20,000 and R to be 1.05. And we are actually looking for sum of the geometric sequence. So sum also means that the value of n is going to be 20. Alright, so we're going to use 20 in this formula. If you were asked to calculate a particular year's profit, be careful to make sure that you use this formula. We weren't asked to do that. We were simply using the sum of the sequence, but this is the nth term formula for certain cases that involve financial calculations. We look at this one more time in the next question. Yeah. So in this question, we've been told that a piece of A4 paper is folded in half repeatedly. The initial thickness of the paper is half a millimeter. We've been asked to work out the thickness of a paper after 4 folds. So, and then we will calculate the thickness of a paper after 20 folds, and we'll have to criticize the model and say why is it unrealistic. So each time you fold the paper, the thickness will double. You agree? So let's just start having a look at it. What we start with is half, and the ratio is 2 because the thickness will double. And we are saying, what's the UN term for n being 4? Now, if you think carefully, this formula is the same as the formula I showed you in the previous question. Rather than 4, we will use 5. Right, let's read the last example here. A piece of A4 paper is folded in half repeatedly. The thickness of the sheet is initially half a millimeter. We've been asked to work out the thickness after 4 folds. Then we will calculate the thickness after 20 folds. Finally, we will criticize the model and say why is it unrealistic. So, what happens to the thickness when you fold the paper? It means that it will double because whatever the thickness is, we're measuring the new thickness to be twice as much. So this is not an arithmetic sequence. The geometric sequence is going to have a ratio of 2 because we are doubling the thickness. The initial value A is half a millimeter. I've just generated this table to make sure you understand what's going on. For the first fold thickness after the first fold, we've already used the ratio once. For measuring the thickness after the second fold, we would have used the ratio twice, and so on. So for the fourth fold, we would have used the ratio 4 times rather than 3 times. This is the pattern that you should be careful with. Certain scenarios require you to understand that the the formula that was originally this formula, this the formula was originally un a r to the power of n minus 1, but that changes now to a un is now actually a r raised to the power of n. Okay, it's up to you whether you want to use this formula. If you do use this formula, you say that actually for the fourth fold I'm gonna use 5, or just it makes more sense to use this formula. So that's why we're substituting value of half. Let me get rid of my writing. We're going to substitute the value of half, r being 2 and n being 4, into this formula rather than a r n to the power minus 1. Okay, so we are not using that. We are going to use this. Alright, so solving the values, and what comes out is 8. Alright, so let's let's understand the next part. Part B is simply asking us to do the same thing, but we're going to change n instead of 4 to be 20. So once again, we're going to use the same formula. We're saying 21 because we are using the very original formula. Now, this is measurement of the thickness of paper in millimeters. That means every 1,000 millimeter is a meter. So this is actually in meters is 524 meters. So now we can understand why the question is saying is it unrealistic or not. Part C is asking us to state the reason why it's unrealistic. Well, your paper is originally A4. That's no longer than 30 or 40 centimeters long. How can a paper 40 centimeters long suddenly have a thickness of 500 meters? It's simply impossible. Okay, so I hope you've enjoyed using these formulas, and you enjoyed practicing, and I'll see you in the next few videos.